Hello, and welcome to Summarize Science. Have you ever wondered why you can't just give an AI like ChatGPT an entire book and ask questions about it? The truth is, processing that much text at once is incredibly difficult and expensive for today's models, but a new paper called Glyph has a radical solution. The core problem is what's known as the context window, essentially, the AI's short-term memory. As you feed it more text, the computational and memory costs explode, making it impractical to analyze millions of words at a time. Previous solutions have tried to make the attention mechanism more efficient or use external retrieval, but they all have their drawbacks. The researchers behind Glyph took a completely different approach. Instead of feeding the model text tokens, they render long pages of text into compact images. Then a vision language model, or VLM, which is an AI that understands both images and text, processes these images instead. This method allows a single visual token to represent many text tokens, effectively compressing the input by 3 to 4 times. The Glyph framework consists of 3 main stages to make this work effectively. First is continual pre-training, where they teach the base VLM how to understand and reason over long documents that have been turned into images with diverse visual styles. This builds the foundational skill of reading the compressed text. Next, and this is a really clever part, they use an LLM-driven rendering search. They essentially use another AI to run a genetic algorithm, which automatically experiments with different fonts, layouts, and sizes. Its goal is to find the absolute best visual configuration that balances maximum text compression with the AI's ability to read it accurately. Finally, in the post-training stage, they take this optimal configuration and fine-tune the model even further to boost its long context capabilities. This last step sharpens its reasoning and text recognition on the visually compressed inputs. So, how well does it perform? The results are very impressive. Glyph achieves accuracy comparable to, and sometimes even better than, leading text-only models of a similar size on various long context benchmarks. It manages this while effectively seeing 3 to 4 times more text than the model's official context window would allow. But it's not just about fitting more text in, it's also about speed. Because the input sequence of tokens is much shorter, the Glyph method leads to a roughly 4 times faster prefill, 4 times faster decoding, and 2 times faster training. This is a massive efficiency gain that makes working with long documents much more practical. So, let's recap. The problem is that feeding massive texts into LLMs is too computationally expensive. The Glyph solution is to convert that text into a compact image and have a vision language model process the image, achieving 3-4x compression. This results in a model that is just as accurate as leading competitors, but significantly faster and more efficient. This approach represents a whole new way to think about scaling AI. Instead of just building bigger models, we can get smarter about how we represent information, potentially unlocking the ability to handle 10 million token contexts or more in the future. Thank you for watching this episode of Summarize Science.